Let me know if you can hear me properly or if there are any audio issues. I know it just restarted. It's still settling up my laptop. It would be better to give another 2 to 3 minutes. All right. Okay, I'll start recording. Oh, it's already started recording. All right, team. So welcome back to this ISTQB Foundation Level Q&A session. So I know now you guys have started preparing. Let me know if you have any questions from any chapters or maybe the questions that you are going through, so that we can take it up and have a discussion around it. Okay, let me open the question bank that we had. Which question? 14, is it? It's been an age that I have restarted my laptop and it is getting a lot of issues. Okay. Sorry for that. Okay. Which of the following is a major task of test implementation and execution? Okay. So it's basically from the testing tasks basically. So which of the following is a major task of test implementation and execution? Okay. Measuring and analyzing the results, reporting discrepancies as incidents, identifying test conditions or test requirements, assessing if more tests are needed. Okay, is a major task. So measuring and analyzing result, that means like after the execution is completed, measuring and analyzing the results, reporting discrepancies as incidents, identifying test conditions or test requirements, assessing if more tests are needed. So what do you think, most of you? B, reporting in discrepancies as incidents. No, I don't think so. Because see, when you're very clear on what needs to be tested, you have your clear expected and actual criteria, and you're performing the task, right? But your more time goes in initial stage where what to test and what not to test. So the most promising answer would, of course, I understand, like when you find a defect, you have to go see if you can reproduce it again. You have to look on which machine you found it, what is the configuration of the machine, what are the different for example, if I'm doing the testing on this, I need to know what configuration of this machine, what other performance of the machine, different users connected to it, different services running on it, I need to do. But nowadays we have tools, just click of a button, you can get all this information in one snapshot. And all these could impact, like the way I'm just restarted, there are a lot of services getting restarted and my machine was slow. Similarly, it could impact your application functionality. But more than that, in the very beginning, we'll spend a lot of time in analyzing what to test and what are our basically test conditions, what we should test, and analyzing the requirements, coming up with our test conditions or test cases. So in my view, at this point of the time, I definitely feel this is the most promising answer. Assessing more tests are needed. Once you're done, it's only a minimal thing that we're talking about. Measuring and analyzing results should not really take much time. It will take a little bit of time in performance testing, but definitely not in functional testing. Reporting discrepancy, yeah, it could be slightly confusing between B and C. Uh, but if you are good in C, if you are good in C, identifying the test conditions or test requirements, that's what I'm saying. Is the confusion is between B and C. Okay. What is developer's job, if I'm not wrong? Developer's job is to write the code, do the development of the application, fix once we identify the issues, fix them, all that. I'm not getting the choice A. That is okay. Okay. No, no, no. Measuring and analyzing the results is totally testing job. It's purely testing task. So after performing the testing, whether it is going in the right way or not, are there any discrepancies? So that is what we have to look. This is all four are testers activities. There is nothing like developer activity here. First of all, okay. And most promising answer between B and C, for me it looks like B, but somebody saying let's see what is there. It's if it is 14th, it says B. Reporting discrepancies as incidents. So incident can lead to anything. It might result in a bug, might not result in a bug. If it gets like, it can be a simple error. So any discrepancy that you feel while performing the testing, reporting the discrepancy into incident. And finally, that after the triage meeting happens, it might result in a defect, might not result in a defect. Okay. So from that angle, probably it's trying to say, but at this point of the time, I still feel planning for your activities, what to test, what not to test. So that will be more challenging. It's a very, very close tie between the B and C, and we'll have to see the words also very closely. So identifying test conditions. Test conditions is nothing but the features what you have to test. By the time you are all familiar with all the terminology, right? If not, there is a glossary at the end of it. You should closely watch it. So test conditions is nothing but the features what you want to test, or test requirements. So maybe is okay. The kind of expectation here is, again, if clear requirements are given, for example, you have a mechanism where requirements are like very, very clear, then from that, identifying what features to test really won't take time. But I'm coming from today's practical way where requirements won't be given very clear. Okay, most of the times we'll have to figure it out a lot on our own. So in that case, this will take time. Like as Sucheta says, it's so you. But the conceptual understanding of this is, if you remember the waterfall model, other different models, like unless the requirements are very clear, we don't go to the design, and then if the design is not true, then we don't go to coding. If coming from that school of thought, then obviously this will not take much time. Okay. But today's practical way is actually this takes more time than logging the bugs, because, and moreover, when the syllabus is kind of designed, we don't have much tools like what we have today. Again, that explanation which I gave in the beginning, if I wanted to capture all my system information, tasks, and everything, just click of a button, I'll get everything. But in the beginning, this used to take a lot of time. I have to go manually check what is my system performance, what is my other users are running, what are the different other services running. I have to go manually check, and there's a lot of time that goes in logging a bug. So maybe from that direction, I was already anticipating it's a close tie between B and C. But yeah, so from the examination point of view, if you have to go, assuming all the requirements are very clearly given to you, this will take little lesser time than this. So I would suggest to go with B now after seeing, because it was all from a traditional waterfall model, what is being assumed. There's nothing like agile. Agile is a separate concept in ISTQB. But in today's world, it's slightly different. This will take more time than this one. Okay, let's go to the next question. 1417. You have designed test case to provide 100% statement, 100% decision coverage for the following fragment of a code. So there is an if condition. So if width is greater than length, you'll have one condition. If width is less than length, you'll have another condition. You have width is equal to length, you will have third condition, like that. But you have to find out the test data in such a way that the least number of conditions in such a way that it will match to the if condition that you have. Anyway, so if some x is greater than y, then biggest dimension is width, else biggest dimension is length, and if the following has been added to the bottom of the code. Okay, at the bottom of the code, print biggest dimension is, and biggest dimension, print width, print length. Okay, 100% statement was covered already. Is saying you have already completed 100% decision coverage. How many more test cases are required? One more test case will be required for 100% decision coverage. Is okay. Let's go one by one. How many of you think A is the answer for this? Do you think A is the answer? One more test case is required for the 100% decision coverage, because there is no decisions being added at the end. It's all through print statements. Decision coverage, and he is saying already you have completed, right? So A will not be an answer for sure. Agree? Team, are you guys with me? Okay, A cannot be definitely answer because there is no decision here. Decision is all completed here. And here you are given an information, 100% decision is already coverage. So A will not be answer. Two or more test cases will be required for 100% statement coverage, one of which will be used to provide 100% decision coverage. Again, he is talking about decision coverage, so B also cannot be answer. Maybe up to here you might feel that this can be an answer, but one of which will be used to provide 100% decision coverage. No, we are already having 100% decision coverage. See, once he got a biggest dimension, all he's trying to do, print the biggest dimension, print the width, print the length. So there is nothing again going back to decision. None existing test cases be used. One more test case will be required for 100% statement coverage. Okay, what is that one more statement? So 100% now you have to choose between C and D, because A and B is clearly ruled out because there is a decision coverage in that. And if you are just thinking about, there are few statements at the bottom. We are already getting biggest dimension here, else biggest dimension here. And either of the way you can print the biggest dimension. So what do you think is the answer? C or D? It will be definitely between C or D, but what do you think? For that, you need to be very clear in understanding what is statement coverage first. Statement coverage is what? Following has been added without condition like if else, simple statements coverage, right? Correct. The following has been added to the bottom of the code fragmentation above. And moreover, these are the simple print statements, not even accepting any value for that. There are two print statements back to back. Does anything come in between the quotes? Which one you're talking about, Sanita? Which two print statements? See, ideally, the whole. So let's assume you're testing this code, right? You will accept a width and length as two inputs in your system, and here is the actual condition being checked. So you need to write a test case to check width greater than length, width less than length, width equal to length. Okay, and if you can identify two values, let us assume. Uh, okay, first of all, how many inputs that are required to test this one? Can anybody tell me? How many least number of? We can actually think of more questions also. How many least number of test cases you will cover to test this one? That could be also one question. Same question can be given. Instead of coverage statements, they might ask you least number. Least number. I can take width is like 20, length is like 10. Right? If I do that, what will happen? 20 greater than 10? Yes. It will say biggest dimension is 20, else biggest dimension is 10. Okay. If I have to test width less than or equal to 20, suppose if I'm taking like um, 10 and 10, 10 and 20, then what will happen now? Width greater than length will fail. So then you will get the biggest dimension as length instead of biggest dimension as width. Now you'll get as length. But you also needs to test what if width is equal to width greater than or equal to length, right? So maybe you have to take like 20 and 20 or 10 and 10. So that's it. If I just take these two values, I'm able to, in a way, the tested data that I would need is just two. Okay. Tested data which I would need is like 10 and 20, or maybe like 20 and 19. Something like that. If I take, I can cover both the cases, all the cases. So that is one thing. So answer should be definitely two. Two inputs is enough. Okay. So in that case, I'm done with all my testing. 100% decision coverage is completed. So the question is only about 100% statement coverage. The statements, main statements, what to display, that is also there. The remaining is all more like a static statements. You can have any number of console printing statements. And this is a simple print command which is given by the language, and you don't need to really worry about much getting printed. So in my view, answer should be C. Nothing existing test cases should be used. Uh, let's see what is there. This is which question? 17. Yeah. So ideally, there is nothing required there because it's good enough because it's already taken care the decisions and it's already taken care the statements, and these are simple print statements, and is printing the same values. There's nothing new there that he's printing. So answer should be C. Is everybody clear? Is everybody clear? Not clear. Okay. Next, what is the next question? Even the question about the number of least number of inputs is also clear. 2 should be fine. 18. A thermometer measures the temperature in whole degrees only. If the temperature falls below 18, so if it is less than 18, one condition. Below 18 degrees, the heating is switched off. It is switched on again when the temperature reaches basically not greater than equal to 21. Okay, the next condition is equal to 21. What are the best values in the degrees to cover all equivalence partitions? Okay, so 15 nowhere in the picture, we don't need, right? 15, 19, 25 we don't need. 17, which is below 18 degrees probably, so less than 18 means we need 17. So there is a chance that B can be answer, but we have to look at closely others. And 18 is also on the border, so we need the 18 also. And 19 is nowhere in the picture, because even if I take 21, the less than can be 20 or 22. Border values can be 20 or 22. So B is not an answer. What about C? 18 is there in the picture, yes. 20 is there in the picture, but 22 is no, sorry, 18 is there in the picture. When it comes to here is clearly saying below 18, it gets that. Okay. False below. Okay. Let's look at B one more time closely. And what is saying, what are the best values in degrees to cover all equivalence partition? You ensure that you covered everything. So below 18 degrees is definitely 17 degrees. So we need that. 18 degrees is border that we need to know, but 19 is nowhere in the picture because it's saying temperature reaches 21 degrees. So we can rule out B. 18 we need. 20, why do you need? Yeah, let's look at the D ones. 16 is nowhere in the picture, 26 is nowhere in the picture, 32 is nowhere in the picture. So what do you think is the answer? Pretty close by is C, right? The reason because for 18 degrees you have 18. For 21 degrees, boundary is like 20 and 22. So you need to check as soon as it reaches 20, is it switching on? 22 switching on, but only 21 it should switch on, right? So the least possible, again, the best possible thing is like C. So this is 18. Question number 18. How come A? Thermometer measures temperatures in all degrees. If the temperature falls below 18 degrees, heating is switched on. No. No, A is definitely not an answer. I think it's 100% wrong. You can, yep, it's totally wrong. It's a C. Yeah, there could be one or two. Not that I'm saying the whole question bank is wrong, but definitely few questions may be wrong. Okay, which active? Okay, next, what is the next question? By the way, others, yeah, I like these are all from, I know Sunita or Sucheta asked. Others, if you have any questions, do put it in the chat. If you're fine with this, I'm fine with this also. Given the following decision table, which of the following test cases and expected results is valid? So generally, what is decision table? When we have to make some decisions, we'll come up with this table, right? We are saying rule one: if age is less than or equal to 21 years, insurance A is applicable, premium £100 is applicable, and excess of 2,500 is applicable. Rule 2 says, so all the insurance companies will have this kind of underwriting rules. If rule 2 says age is between 21 and 29 years, insurance A, policy A can be applicable, policy B can be applicable, and the premium is 90 and excess is 2,500. Rule 3 says, what the hell is this data actually? It's totally reverse. If the age is more, premium will be more. Anyway, we should not worry about that. What we need to worry about is like what is given to us. Okay, Rupal says I have some question. Where is that gone? Do we test functional and non-functional in system testing? Do we test functional and non? System testing is nothing but end-to-end testing. So in end-to-end testing, yes, we do take care of functional testing, non-functional testing, security, performance. Depends. We have to. Generic answer is definitely yes, but in the context, we have to see what is being asked. If that is the only question, then yes. Is component functional or non-functional? Component is unit level testing. So typically, this is my generic formula which I will try to do. First, it always starts with unit testing, right? Unit testing, and then we go to integration testing, which is like system integration testing, and then we do system testing. This together is generally I would call like functional testing. In functional testing, you'll definitely do this. So your question is component functional or non-functional? So that is unit level. It will be mostly, it comes under white box testing, if at all, even you have not asked that, but I'm just covering. And most promisingly, it will be a functional testing. Verifying the individual unit is working fine or not. You will give different inputs and check different outputs. Very less on non-functional in terms of like at a small unit level, performance checking is very less chance. But when we start integrating, then that also, even integration testing, it's majorly functional testing. And this is like a, we call it as a gray box testing, because here code level also we need to check, functionality also we need to check, and this also majorly functional testing. But system testing we'll have to do end-to-end verification, system end-to-end verification. Again, from a functional point of view, if you're talking, majorly that goes, and that's what I will call it as functional testing. So functional testing is nothing but unit testing plus integration testing plus system testing. But before we definitely sign off the system, then we'll have to do various non-functional testing. So Drupal, to answer your question, it is functional testing. Unit testing is functional, your component is functional, non-functional, functional testing. Okay. Let's look at this data. And rule 3 has given some data. Rule 4 he has given some data. And then he's saying which of the following test cases and expected result is valid. So unless you read all the 4, we cannot really derive. At 23 years old insurance. Okay, 23 years, where does it come into picture? He'll come into picture here. At 23-year-old, insurance class A, yes, he can get ARB. So A, premium is 0, he's saying. So this is wrong. A 51 years old insurance, 51 years, he's definitely here. Greater than 50, not even greater than or equal, so greater than 50. Old, 51 years old insurance, class C, yes, CRD. Premium is again 0 and excess is 0, wrong. 31 years will come into picture here. 31 years old, insurance class B, it can be B or C or D, so B is fine. But again saying, okay, all the questions have premium 0. 31 years old, insurance class B, premium is 0. Excess is 500. Excess is 500 is correct, but premium is 0. In first two options, even excess is wrong, right? For example, 23, excess is 2500, so straight away wrong. B, excess is 00, straight away wrong. At least now C, excess is correct. So he's saying excess is correct, but premium should be 70. Okay, let's look at the last one. 43 years old, 43 years again comes here. Premium is 0 and excess is 00. So this is definitely wrong. And with a print mistake or any reason, C could be answer because this could have printed wrong. Okay. So which question is this? 21. 21A. 23 years old insurance. By the way, 21 definitely comes. 23 comes here. 21, 29, right? It's class A. That's fine. Premium is 0 is wrong. Excess is 0 is wrong. So that question is wrong. So anywhere it could be like most promising is C. I think Sucheta, mostly just because these inputs are incorrect, maybe you had a confusion for few of them, but otherwise this is not a very complex question. So all right, maybe the other questions also in the similar fashion that you're thinking, or you're expecting some, because in this question there's nothing like that. Anybody has any other thoughts on this question? There's nothing. It's straight away decisions are given, and from the decisions we have to derive the statements. That's all right. Any other generic questions that you have? We'll look at other questions also, but meanwhile, question number 36. Okay. But before that, Sucheta has 33. So let's look at 33 and 36. Match the following terms and statements. Decision table testing, decision testing, state transition testing, exploratory testing. And W statement says testing carried out with the boxes to achieve specific test objective, possibly to complete structure testing. Testing carried out. Match the following terms and statements. Testing carried out with boxes to achieve specific test objects possibly to complement structure. A test technique used which may be used to verify different system or depending on the current conditions or previous history. A test technique which combines combination of inputs that might not otherwise have been exercised during testing. A form of control for testing based on decision outcomes. So what is JED? A form of control flow testing based on decision outcomes. That is nothing but decision testing, right? So 2Z, wherever 2Z is there, point to that answer first and think about other options. What Y says, a test technique which combines combination of inputs that might not otherwise have been exercised during testing. And what one is saying, decision table testing, a test technique which combines combinations of inputs that might not otherwise have been exercised during testing. So which is decision table testing, right? So at this point of the time, after reading two answers, most promising answer is A, but let's look at others also. 3, what is state transition technique? What exists? A test technique used which may be used to verify different system or depending current conditions or previous history. Again, seems to be the right answer. 4W, what is W? Testing carried out with boxes to achieve specific test objective, possibly to complete structured testing. Okay, at this point of the time, A looks to be very promising answer, but that does not mean that we cannot rule out others. Okay, 1X, decision table testing. A test technique is to different system or depending on current conditions of previous apply. No. See, if you have one or two strong answers, right, you should be able to reach. Z is very strong answer. A form of control flow testing based on decision outcomes. Nothing but your decision table, right? Decision testing. A form of control flow testing. So this is definitely 2 is Z only. So it is 2Z. And you can see there is none other places you have 2Z. But there is a small confusion between this Z and 1 also. So you need to rule out like 1Z is in two places. If at all you think decision, I mean, while doing the real exercise, right? Decision table testing, if you're confused with that, look at others. For example, let's look at D, 2Y. 2 is what? Decision testing. Y says a test technique which combines combinations of inputs that might not otherwise have been exercised during testing. And 3X, state transition technique says a test technique which may be used. That's also similar. 4W, exploratory testing. Testing carried. See, this 3X and 4W is pretty much same in 1 and sorry, A and D also, but you need to rule out between this 1Z and 2Y. Okay, small confusion, right? You can see 1Y, 2Z, 1Z, 2Y, because 3X, 4W is matching in both the places. Now, if you have to rule out this, you have to observe very closely. One of them you have to take, 1Y or 1Z, or 2Z or 2Y. Decision testing, decision table testing. Decision table testing we just saw in the previous example. Okay, that is one. And if you want to rule out Y or Z, a test technique which combines combinations of inputs that might not otherwise have been exercised during testing. A form of control flow testing based on control flow is based on the decision testing. There's nothing much to think. So it is decision testing, that is 2Z. So it should be A only. 33 should be A. Okay. Did you reach how we should, I mean, did you figure it out how we should reach? How we should answer the questions at least? If you start reading everything, you'll get confused. Read out one thing that you are very strong and read out one thing, and then at least you will rule out half of the answers. But again, before you go tick mark, definitely read out others. What do you feel is a strong answer? Just keep an eye and note it here. But others, at least check once, because you might forget something or you might leave something. I was a little confused between this 1y, 2z and 1z, 2y, because this 3x4w, 3x4w is there in both the places. So you have to take that way. All right, somebody is saying 36. Which of the following types of defects, now coming to types of defects, is use case testing most likely to uncover? Which of the following types of defects is use case testing mostly likely to uncover? Okay, so he's talking about testing with some use cases, which is, like, to be frank, little older process. We're not doing that now, but we have to go with the exam. Defects in the process flow during real world use of system. Defects in the process flow. So what is a use case? First of all, like a real user coming and using the system, like you'll visualize what if a real user goes to an ATM machine, what are all he can do. He can swipe his card, he can check the balance, he can withdraw the money, he can print a statement. So you have to really, I mean, when you are before designing that system, you have to think those use cases. No, performing is acceptance testing, but you are in the very beginning now. You are in, like, development phase. The developers are writing the code and you are writing your test cases. Just that only you have requirements and design with you, but system is under development. Acceptance testing, when it comes to picture, acceptance testing come into picture after we do everything, after we sign off, give it to users. Now the bank people will test the machine working or not. That is acceptance testing. So we are talking about a way early. A banking system has given a new requirement, what they want to do, and we have to sit with the banking people or the product people to understand how a real user will use this system once we give it. That is use case. Defects in the process flow during real world use of the system. Defects in the interface parameters in integration testing. So one thing that you can do is use case testing. Which of the following types of defects is use case testing most likely to uncover? So the question is on the reverse side. Okay. Definitely, first one promise, if you can see, defects in the process flow during real world use of the system is nothing but use case testing. But he is saying that is most likely to uncover. So one is not your answer. In that way, you can rule out B and D. Of course, once we got the answer, we'll come back and check. But for now, you can definitely rule out B and D. Okay, let's come back and look at defects in the interface parameters in integration testing. Integration testing is not a use case testing, right? So there is a highly chance that, these two will be present in the answer. So 2 is present where and where? 2 is present in A as well as D. First, what did we rule out? First one, wherever 1 was there, that is B and D we ruled out. But now second answer is making us to think A and D. Okay, let's keep that. Integration testing defects caused by the interaction and interference of different components. Third one is also similar. Defects in the system as it transactions between one state and another state. Defects in the system as it transitions between one state and another state, that is state transition technique mostly. So most promising answer is A, but again, let's look at every other answer now. B says 1. What is 1? 1 is definitely use case system, so not a B. C says third and fourth. Integration defects caused by this. Defects in the system. Since D has 1, D is also not answer. B has 1, 1 is also not answer. So answer could be between A and C. So let's try to rule out now. Is there anything that is common in A and C? That is in integration defects? Yes, that is there. That's okay. What about second? Defects in the interface parameters and integration testing? Yes. Defects in the system as it transitions between one state and another state. So this is more like a state transition technique. Most promising answer is A, but there is a chance that it can be C also, but mostly A. 99% is A because it's talking about integration testing, and third one is integration between two. So let's look at it. Should be B. 36. 36 is B. Right, so because this last one is more like talking about transitions between one system and another system. That's more like, again, after the system has been built, how user can transit from one system to other system. Clear again? How did we arrive the answer? Frankly speaking, I saw this question back long back, maybe around 3 years back, 2 years back. So, but the way, and it's totally fresh in my mind right now, all these questions. So all you have to do is derive in the way we are going. Take one by one and try to figure out the answer. Error guessing is, as the name says, guessing an error. So you will guess error could be in component 1 or 2 or 3 based on many other things. Based on, for example, there are 3 modules in the system, and I know module A is very simple and my developers have developed like very easily. But I know module B went through a lot of code reviews. Before even implementation, there were a lot of email exchange between client and the engineer. So there is a high chance that my developers will do mistake in module B. So I will go test module B thoroughly, and then I will definitely find the bugs. So that is like guessing, error guessing technique. Guessing the errors where they will be. How do you guess? Based on the complexity of the feature, based on not clear requirements, based on design was not clear, based on very frequent changing of the requirements. Initially, they told this is the formula, that's how we should calculate discounts or whatever. And again, they said, no, no, that's not a wrong formula, let's do it this way. And then again, they said, no, 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 let's do it this way. So there are so many times changes happened, then there are high chances of finding the bugs. So that is the technique is called error guessing technique. Biggest potential cost saving. What is that, Rupali? Is a statement, question, what? No, unless you give me the 4 options, because it's a very generic term. Biggest potential cost saving could be anything. So based on the 4 options that we will have, we'll choose the best one. Is it answer of error guessing? That's what I'm saying, Rupali. I need to know the other 3 also. Yes, it could be one of them. Biggest potential cost saving could be, I don't know in what context we're talking about. If I have the question, I can explain, because those are 2 very generic statements. Error guessing is a technique. Biggest potential of cost saving, yes, it might, but from a quality point of view, not a good option, right? So I need to look at what other 3 answers are, then we can best answer it. All right, let's look at other questions. Anyone has any other questions? Let's look at the 40th question otherwise, which Sujata asked in the beginning. Which of the following is most characteristic of a specification based? Specification is based in nothing but black box testing technique, right? Which is the following, which for the following is the most characteristic? Test cases can be easily automated. Test cases are independent of each other. Test cases are derived systematically from models of the system. Test cases are derived systematically from the delivered code. What is black box testing without testing the internal logic code or code behind the system. If you consider that, D is definitely not an answer. He's saying test cases are derived systematically from the delivered code. 100% D is not an answer. Test cases are derived systematically from models of the system. Before coding, generally the developers will come up with a different model. It's like models are nothing but the kind of flow charts, okay, which will explain how somebody can enter into system and what are the different paths they can go. It's like a model, or I would say a flow chart kind of thing. There is a chance for C. Let's look at others. Which of the following is most characteristic of specification testing? Test cases can be easily automated. No, we cannot say that, right? Black box testing goes on specification. That doesn't mean that test cases can be easily automated. No, A also cannot be answer. A and D is gone. Now between B and C. Test cases are independent of each other. Test cases are independent of each other. That also you cannot say, because there could be one test case which will have to perform first to three steps and then have to go 4, 5, 6. There is another test case which you have to perform first three steps as it is, and but the fourth and fifth steps are too different. So you cannot completely say test case 1 and test case 2 are totally independent. No, all the dependent test cases, related test cases will bundle into something called test suite, right? So the most promising answer is C here. Test cases are derived systematically from models of the system. 40, right? Models is nothing but, as I told you, it's kind of a, uh, without knowing the code, it's like, okay, simple. If anybody does not still know model, okay, here is an entry point into my system. Then you will enter into the screen, and then you will be checked what kind of a permission you have, whether you are an administrator or normal user. According to that, you will be given an access. So this is like a flow, and then based on this, you can generate a report, and then you can log out, and here you can perform this operation and log out. So it's like a model diagram flow chart. For this, I don't need to know the code. So this is like a purely black box. Based on the black box, we know the functionality, we can write the code. So answer is C. Clear, Sucheta, now? All right. What is cyclomatic complexity? You guys remembered what is cyclomatic complexity? The second formula. So simple. In if you have to remember, right? You have a code, and let's say there are two conditional statements. Okay, or let's say you have a conditional statement which can lead into two paths. So in that case, simple, your cyclomatic complexity will be 2 plus 1. Okay, if you have a simple if condition. If, for example, if there are no conditional statements at all, there are no conditions at all, it's all simple linear statements, then the cyclomatic complexity will be 1. You have just plain statements. It could be 1,000 lines of code, doesn't matter. Cyclomatic complexity is 1, because there are no different paths. You are going in a straight way. Suppose you are reading value and you are printing this, and then you are reading, and then you are doing some no check, nothing, and then you are writing to database, or then you are doing, so it's all cyclomatic complexity 1. But you have a condition here. Okay, you have a condition here. Based on the condition, you have two paths. You can go here or you can go here. Then the cyclomatic complexity becomes, now this can leads to 2. So your cyclomatic complexity becomes conditional statement. So 2 plus 1. So like that, if your developer is writing more and more and more conditions, the complexity becomes more, and the testing becomes challenge. So that's what is cyclomatic complexity. Okay. If you guys want to see, we had that formula. This is how I generally straightforward remember, but let's just go and anyway, the notes you have. Okay, there is one. Again, the same thing. I really don't know. You can pick it up from anywhere. As long as it's helping, it's fine. But okay, let's pick up the example that we had. Was it in chapter 5 or 6? I don't remember. I don't think it's in 5. It's 3. We'll come back to the questions, Suchita. Let me just, because I think in the last class also somebody asked about this. Is it here? No, this is like review techniques. Is it 4? And it's a purely white box testing technique. Okay, we generally don't do it so commonly because most of the jobs that you get in either will be purely black box, but there will be very few on white box also. So you can see this is like p plus 1, where p is number of nodes that contains condition. Like, so in our case we had two conditions, right? If condition yes or no, so that is 2 plus 1. That's why I told you the cyclomatic complexity. Just identify number of conditions, and plus 1 is the cyclomatic. Why that plus 1? Because for that linear statements plus 1, and conditions you have 2, so 2 plus 1 will be the cyclomatic complexity. Like that, if you have more and more conditions, then you have to identify. The other formula to remember is E minus n plus 2p. Whereas so you will come up with a graph and then identify how many edges are there in the graph, how many nodes are there in the graph, and how many connected components are there in the graph. So I generally don't go with this formula, but simple to remember is p plus 1, where is number of predictable conditions and then plus 1. This is the simplest way to calculate. Okay, and this one to remember, like, I don't think you will get any questions, but this will help you to rule out some of the conditions. Suppose he says he's give you some code and let's say the cyclomatic complexity of this code is 20 or let's say 25, and then these points will help you. It's a very complex code, low testability, cost and efforts are high, so that kind of thing. All right, what's the next question? 78. Oh, you have a question on that? 305, we'll look at it. 78. Which is not a component testing. Component testing, I told you, unit testing, right? Check the decision tables is definitely not a component testing. Check the branch coverage is not a, which is not a component testing. Okay. Checking the memory leaks. Checking the robustness. Check the branch coverage. So in your unit or a component testing, obviously, suppose we'll say smallest part of the component, and here is the code of that, but that code can have conditions, branches, right? And that code can also, so This can be definitely one of the component testing. In the component while testing, unit testing, whoever is doing, he has to check both yes condition, no condition, etc. So checking the branch coverage is definitely part of it. Checking the decision tables, like suppose I developed a small unit component, but in that smallest component there are some I would say like whether is if we go back to the insurance company and let's say I'm taking this premium calculation screen, based on his age I have to derive where he belongs, so what is a premium and what is the excess. So even the decision tables will be part of it. Checking the memory leaks as a small unit, if you cannot avoid the memory leaks now, and if you start integrating your system with other systems, it will even have a much bigger problem. So we'll have to even check if there are any memory leaks. So at this point of the time, the most promising answer looks to be like robustness. Robustness is like a performance. As I told you in the previous explanation, unit testing or component testing is more like a functional testing. Okay, the performance will have so many other, like, it's even if okay, you have to eliminate the performance if there is anything in the system, but as a unit level there is a very less chance for you to test as a performance, because even if you do this underwriting logic or whatever, it may need to connect to database, so your database come into picture, or maybe other system that you have to integrate, so that becomes integration testing. There is a less chance for checking the robustness at unit level. So let's look at what is that 78. I'm thinking mostly B. 78D. What is the check the decision tables? Decision tables at unit level. But with the same explanation that I gave, if I'm testing a small unit which is the same insurance form, a single form, I might need to test decisions also. If more, I would not be really doing the robustness performance at unit level for sure. Okay, I'll get back on this. Let's have a little bit more research, because for me performance is not something at unit level. Okay, I'll remember this question. We'll do that. Okay, 82. Which is not the software characteristic? Which is not the software characteristic? A software has to be reliable. Software has to be usable. Software has to be maintainable. Very confusing answer. In fact, all four actually applicable. So there's nothing like we can leave, but we have to choose the not so very important one. Okay, any guess what could be the answer for 82? Reliability is okay. First of all, everybody clear with all these terminologies? Reliable. For example, you have to go from place X to place Y, and you will take the help of maps today. And I don't want to name anything, but there are different maps available, and you will go choose one of the one that is reliable for you. One map may be very good in your area, but when you go to the other city, there could be another map which is very reliable. So that's what is reliability, which is more accurate and always gives you correct. Or let's say you go and ask for a weather report in so many options that you have today, and over a period of time you will feel one of the site gives you accurate or reliable information. So you'll then after that you start going to that. So that is reliability. The information that is available on the application or website is more reliable. Usability is user friendliness. It's not very complex to use that. Like again, we have different versions of smartphones: Android, iOS, Windows. So which is user friendly? For some set of people, they say Android is best. Some set of people say Apple is best. So again, how user friendly it is. That is what is called usability. Scalability is like we have designed a system, assuming that it's going to serve for 1,000 people or 10,000 people, but in the next 5 years, we're going to have like 1 lakh people. Can the system be scalable to that? So the more number of people gets added, can it scale to support that many number of people? Okay, that is scalability. Maintainability is like you designed a system and given it, and then it has lots of issues. There are a lot of bugs and there are a lot of enhancements that needs to be taken care. So we say it's not a very good maintainable system. So it requires a lot of maintenance, right? So maintainability should be simpler and use. Okay, which is not the software characteristics? Want to take any guess after explaining all the options? When we are designing the system, actually speaking, we'll consider all this. I mean, to my testing team and all, I'll keep saying you have to check usability of the system, even give inputs from scalability point of view. Even after the system is gone live, we'll give a free maintenance for a couple of months. So maintainability is important. Yeah, could be mostly C. Promising answer is C, as you guys are also guessing. Let's see. 82. See, scalability is something like down the line in next 5 years, next 2 years. But actually, in today's, again, this kind of little age-old concept, we'll consider scalability also into picture today. In fact, all four are software characteristics. But if we go with the order, then C comes last. Okay, 83. The principle of cyclomatic complexity, considering L as edges or links, N as nodes, P as independent paths. So I just explained M minus N plus 2P, right? So that is L minus N plus 2P. Where is that document gone? So this formula is as it is given. E minus N plus 2P, there it is L. So E minus N plus 2P or L minus N plus 2P is the answer. This one. 83. Oh, no, we have to read. L as edges. In our case, it is what? What is edges? E as an edges. Correct. Then it's A. 83. A. Okay. 101. Oh, what is this? Okay, I'm reading the options. Okay. The switch is switched off once the temperature fall. I think we have seen this similar statement below 18, and then it is turns on when I think the same question when the temperature is more than 21. Identify. Now of course the inputs are different now. Okay, same thing, but the explanation which I gave you, 12 is nowhere in the picture, 24 is nowhere in the picture. Um, I think this is wrong. All the inputs are very different. Okay, let's look at what identify the equivalence class which belongs to the. Oh, no. The question is very different. Okay, this is an interesting question, by the way. Identify the equivalence values which belongs to the same class. Okay. The switch is switched off once the temperature falls below 18 and then turns on. So you know the boundary values. And he's saying identify the equivalence values which belongs to the same class. 12, 16, 22 is nowhere in the picture because they are very different. 24, 27, 17 also very different, and 21 22, 23, 24 is kind of sequence, but do we need these inputs anywhere? 22 is required here. 14, 15, 19 is nowhere in the picture. In what way you're saying Rupali C? What is your idea behind C? Switch to advanced temperature force lighting. That is one class. Okay. See, this is how you have to do. So less than 18. That means 0 to 18 will be one class. Okay. I'm sorry. 0 to 17 will be one class. Okay. And then 18 is another class. This is how you have to do. Otherwise, you will get confused. Then, and it is turned on when the temperature is more than 21. So 21 to anything, 22, 23, 24, 25, 26, up to infinite one class. Okay, this is exercise you have to do. Otherwise, you will not get into there. Then your minus numbers will be 1, and then you above whatever. So if you see that way, 21, more than 21 is it. So 21 is going to be another class, C3. 22, 23, 24, 25, 26 will be another class. So that way, if you see, yes, C is the answer, because they all belongs to one class, 22, 23, 24, 25. Is it clear, everybody, this explanation? You have to make this, otherwise you will not come in. You have to categorize all the inputs. Below 18, one category, that is up to 17. 18 is a different category. 21 is a different category. 22, 23, 24 up to infinite will be one category. Negative numbers one category. Characters one category. Special characters one category, right? And then he's asking which are all belong to the same class. So obviously this. So 1 at 100% should be C. Okay. All right. Okay. There's one question on the cyclomatic complexity. Question number I forgot. I just have another 5 minutes time. Not even 5 minutes actually. Let's look at 3 not 5. By the way, if you guys need us any more sessions as you prepare, let us know. We'll have one more session, maybe like 1 week, 10 days down the line. So that once you have set of questions, pool like this, but you need to definitely put a lot of efforts in taking up all this, and definitely note like Sucheta, thanks for this all questions. In fact, it might have helped others also. Cyclomatic complex is used to calculate number of independent paths in a basis set of a program, number of binary decisions plus one, number bound for the number of tests that must be conducted to ensure that all statements have been executed at least once, number of branches and decisions is your branch testing, number of independent paths in the program, yes, number of binary decisions plus one. That's not the overall idea. Cyclomatic complex is used to calculate what? Okay, to calculate number of independent paths in the no, that is A is not the answer. Number of binary decisions plus one seems to be promising. Number bound for the number of tests that must be conducted. No, the promising answer seems to be B. Because I've explained it, right? It's a conditions plus one, but let's look at what is there. Okay, it's the conditions plus one. It's to calculate that. All right, so with this, let's take a pass here. All are more than 21. Okay, yeah, I think you understood it, right? Fine. All right, team. So please let us know as you prepare how it's going, and if you need any help, maybe down the line a week from now, we can have. Anybody already signed up for the exam? When is your exam? Anybody signed up for the exam already? Not yet. Okay. Look into your place, country, sign up for it, and then take it up. Then that'll be more, definitely more. I mean, okay, if once you understand these 5 minute questions, if you have got a confidence, watch the video again and then do it. Okay, you're planning to take the end of this month. Super. All right. All the best to Cheta. Yeah. So, as you say, please let us know. A week from now, I'll plan to do one more. Which is the following is not included in the test plan? 306. Features to be tested, environmental needs, suspensions criteria, expected results. Anybody would like? It's a very straightforward. What is test plan? So you have to be very clear what is test plan, test case, test condition. Then expected result. Why will you write expected result in? No. Suspension criteria has to be part of the plan. So we'll say like yes, exit criteria. Suspension is not exit criteria. We'll suspend the testing if major things are not working. We'll suspend the testing. Like sanity testing failed, BVT failed, or no, we are suspending the testing because we are not able to proceed. And that you need to have kind of a criteria. Why will you have an expected result in a test plan? Expected result will be part of a test case. Right? So D is the answer. First three, what features to be tested, which environment to be tested, what is the suspension criteria, why are you stop? Because you cannot just stop the testing and say we are stopping the testing. People will question. So, but if we have already taken in the test plan and communicated to everybody, we are going to stop the testing. If these things are not going to work, then you are good. So D is the answer. All right. Thanks, everyone. Have a good preparation. Yeah, well, I'll ask the team to set up one more as soon as possible. Thanks. But we can also exchange the emails. So do send us emails if you have questions, and then or else pull up the questions like this, and then we'll have discussion. Thanks, everyone. Bye.